Hello and welcome to today's SQL Office Hours. To start off with, we'll introduce something which some of you may be familiar with, a problem that you may have encountered. So we've got a few tables in our database, customers, orders, and invoices. And there's some columns which store similar values, which might be in all of these tables. For example, email or email addresses. And in the customers table, it's an email, and we've declared it as a varchar2 555. Over in the orders table, got a slightly different name, email address, but it's a varchar2 320, slightly different definition, but still fairly similar. And over in invoices, it's called customer email, but it's in nvarchar2 999. It's like, okay, doesn't quite fit the pattern here. Or maybe you've got things like an insert timestamp. So over on the customers table, it's called insert date, and that's a date. On the orders table, it's an insert time, it's a timestamp. And on invoices, it's an insert timestamp, and that's a timestamp with a time zone. All right. I think many of us seen things like this where columns which store the same values and thus should have the same definition have slightly different names and maybe even different data types across different tables. And, this is kind of understandable because database schemas can be pretty complicated, right? There's lots of tables in them, and tables can be added to them over time. And this can happen over, months, years, or even years, sometimes even decades. And it can be difficult to know if you're coming to a new application, new schema, what conventions to follow, whether a value exists in another table, and so on. So it's tricky over time to keep these kind of consistent definitions, use the same name for the same type of values and the same data type. But this is just part of the problem. When we think about values that we're storing in a database, usually, the end users of your system, the consumers, think in kind of terms of real world objects or business values, things like credit cards, numbers, monetary currencies, that kind of thing. But when we store them in the database, any context of what they are, the format, the structure of them, we tend to just put them in as a string or a number or something like that. And we've just got that base type in the database. That means when you fetch it out of the database, it's basically just a string or a number or a date or something like that. So we've kind of lost the context of what the value actually is. For a credit card number, it's got to be 15 or 16 digits. Phone numbers have particular formats depending on your country, that kind of thing. So we've lost the context of how we display the values. And there may also be rules about how we actually store these values as well. Only certain numbers are actually valid credit card numbers, for example. So how can we keep this original context of the values? And this becomes particularly tricky as it's quite likely that there's actually several systems that access your database. You've probably got your web app reading the data, and there might be a separate app for mobile, like a mobile app for it. You might even have a desktop app. So there could be several of these. And of course, you probably got duplicates of these. You've got an Android and a Apple app, iOS app. You might have a Windows and an iOS desktop app. And you've probably got multiple web apps as well for various reasons. And keeping these things consistent can be challenging, particularly if you've got like 1,000 microservices all trying to access and read these values at the same time as well. So how can we kind of standardize these values across the apps to make sure that they all interact with them in the same way? After all, a credit card's number has the same rules and principles, whichever app you're using. You want them all to use it consistently and uniformly across your application. So how can we do this? Well, we're going to look at two things we've introduced in Oracle Database 23 AI to help you with that. That are schema annotations and data use case domains. So we will dive into the details of those today. So hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's app dev team here at Oracle. It's my job to help you get the best out of Oracle Database and hopefully have some fun whilst doing so. So as I say, with that in mind, we're going to look at schema annotations and data use case domains in Oracle Database 23 AI. Before we get into that, just the announcement. So earlier this month, back on the 2nd of May, we announced general availability for Oracle Database 23 AI. If you want to try it out and play around with it, you can do so on Oracle Cloud. So the always free autonomous databases are available. There's only some regions it's available at the moment, but we'll keep adding those over time. And there is Oracle Database Free, which you can download and run on your own machine. There's also various kind of cloud services you can use as well to run Oracle Database. So if you want to try it out, check out those resources to see what's there. And I really do recommend you check it out because 23 AI is a massive release. There is a huge number of features in here, some of which are kind of tiny SQL features that people have really been asking for a long time. Things like, let's say, tiny Boolean data type, maybe not tiny, but kind of smaller features, but also kind of big things like JSON relational duality and property graph queries in SQL. And as we'll see today, we're going to look at data use case domains and schema annotations. So to do that, let's just imagine that we are building a simple retail schema, some kind of shop front application. So in there, we've got the standard objects you might have. We've got customers, they place orders, there's invoices for products and order items, so on. So the tables here aren't really the interesting thing, or the thing I'm going to focus on. What I will look at more detail is the values, the common values. So there's some values which we're going to have store in multiple tables. First off, an insert timestamp, right? When each row was inserted into the database. And properties for that is going to be system generated. It's going to be a default value, essentially. Then we've got email addresses. So they are strings containing an at, basically. We've also got statuses, things like whether an order or invoice is open, closed, paid, refunded, cancelled, that kind of thing. Currencies, more monetary values. So products have a price, invoices and orders are how much you paid, things like that. And then there's addresses, where we're actually sent physical addresses, where goods are going to be sent and that kind of thing. So as I say, these values are likely to be stored in many of these tables across the application. So the key thing here is we've got these properties and we need the application to know what these properties are, so work with them consistently. So the question is, how does the app know this? How can the app know what these particular values are? Now, one way you could approach this is to create types. So we could have actually come up with a rich type system in Oracle Database. For example, we could have created a type for an email address, a type for money or currency, a type for insert timestamps, and so on. Or you can create your own user-defined types, which seems like a good idea at first. It's like, well, you've got specific logic and handling for that. But you can come up with really rich type systems, but there's no guarantee that people are actually going to use them. For example, let's take a type types that have been around for a very long time, dates and timestamps. They've been around for basically forever, timestamp for a couple of decades now. You'll still see people doing something like this, creating a table with an insert timestamp column, which is not a date or a timestamp. It's, a string or maybe a number. Hands up if you've seen something like this. I know I've seen people do things like this more often than I would really like them to, right? You can come up with these really rich type systems, but there's no guarantee that developers know they exist and then will use them in appropriate ways. So, there's, the thing of having a lot of work for kind of people then not actually doing it, which is a bit frustrating. But there's a more kind of general important point when you come up with types. So other databases do have more kind of richer inbuilt type systems, but the types they provide can come with limitations. So a common example is money. Some databases have a money system. But if you look up what people think of that, you'll find advice like this: don't use money, right? So Postgres actually has a money data type, but you'll very quickly find a lot of articles and advice saying you should avoid it. Similarly, SQL Server has a money data type. People saying avoid using these data types. It's like, well, we've got these types. Why avoid using them? Well, the exact reasons obviously vary between systems. But it comes down to the fact that they have a specific definition and support a specific use case. If you don't fit that specific definition and use case, then you run into trouble potentially. The values may not be represented how they work, how you want them, They aren't necessarily supported by all your standard functions you know and love, like sum, average, min, max, and so on, things like that. So generally, having these types add complexity. And if you think about it, if we kind of try and create our own user-defined type, so we create our type, an insert timestamp with an object, we can use that as a type for our table, but we can't interact with that insert date time column like a regular column. We try and do things like max, min, and so on. It gives you lovely errors like you can't order objects, right? Using types adds complexity. Either that means we need to build it in the database, do a lot of work to kind of support all operations and make sure it works in the way you know and love, or you need to build it in your application in terms of custom handling. Now, I know some of you are going to point out you can do things like actually access the attributes of it. But the point here is you have to do something special and a little bit different. You can't just use it like a regular column. Extra work needs to be done. So overall, we kind of think types do have advantages, but generally they need special handling. And a lot of the time, this extra complexity isn't worth it. So we've gone down a different route here at Oracle, and we think, well, these kind of base types, number, date, and string are universally used, hopefully used anyway, in the case of date, and they're very widely supported, and all the inbuilt operations work on them out of the box. But as we say, we lose context for what those values represent. So we're coming up with what we call class of language statements we call data intention language. So represent how you actually access this data, your intent for using these values. So as I say, when it comes to what we're discussing today, we're looking at schema annotations, which are a series of key value pairs, which are application metadata. So this is just information for other developers, applications to read and use and understand those values. Then we've got data use case domains. So these extend the base type, so number, varchar, string, date, and so on, with usage information about how they actually interact with values. So we can describe the value and ensure it has certain properties in the database. So let's see these in practice and see how they work, and start with those common values we're going to use. We'll start with our insert timestamp. Now, we want every table in the database to have our insert timestamp column. It's really common, it's useful for things like auditing, debugging, so you can know when each row was added to the database. So we can create our tables and have our insert timestamp columns or date time columns with a timestamp like this. Now, the key thing here is they've got special properties or certain properties which we want the applications to respect. First up, they are system generated. So what that really means is we don't want the application to provide new values for them. So don't insert your own values, don't update them. The database is going to generate them for you. But we are going to create some indexes on these columns, so it is okay to use these in a where clause and order by and so on. So we want to allow users and applications to filter and sort on these values. So how can we share this information with the app? How can we let other developers and applications know and infer or see this information? Now, one approach you could take is column comments, right? And it's like, this has been around, I don't know how long it's been around, very long time, as long as I can remember anyway. You can do comment on column is blah, 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 right? And you can stick whatever you want in there to describe the value. And it's like, well, yeah, you can, but as I say, ed is just one big long string. It's just one big long value. If we're trying to put our properties in here, we've got system generated, insert, update, where, order by, and so on. What does this mean, right? How do we extract the values? How do we turn this into something useful? Now, some of you might say, okay, we could make it, structure it as JSON or XML or something like that. It's true, we could. But again, that's a decision you've got to make as a team, as the people working on the schema, to know, okay, this is the format we use, these are the tags we're going to use, and so on and so forth. So it can work, but it is a bit clunky and it is a bit fiddly. So this is where schema annotations come in. So allow you to record this kind of properties and metadata. And what these are, they are a series of keys with optional values, key value pairs you can store against your columns in the database. So we can do something like this. We can alter the table of our column, excuse me, say the annotations. say it's system generated, and we've got clauses to add or replace them as well. So we can say what rights are disallowed, don't allow insert and update, allow people to filter and sort, use it in the where and order by clause, and so on. Once we've defined the annotations, all annotations for all objects appear in the annotations usage views. So we can query that, we can look up our column, and we can find our properties a bit like this, okay? So with our annotations, we've got all of them in one place. And this is different to comments. With the comments, you can have comments on, I'm trying to remember, columns, tables, I think views, maybe one or two other things. And they're all sprayed across the data dictionary, and they're all in their own location. All annotations are in the same location, no matter what we're annotating. So we can also annotate tables, we can annotate materialized views, and something people have been asking for ages, not commenting indexes, but annotating the index and say why they exist and what their properties for are, and so on. So at this point, I'm going to jump over to a little demo and just show how these actually work in practice. Next, if you've got any questions, comments on this, just let me know in the chat, or Q&A, I should say, rather than chat, so it's easier to follow, and we'll follow that. So I'm running this, so I'm using the VS Code, SQL Developer VS Code extension. So just those of you who don't know, earlier this year, Oracle SQL Developer, the desktop app, we've now got our Visual Studio Code extension, and that's going forward is really the way you should be using it. Okay. Anyway, so I'm using this, and we'll create our customers table. We've got our insert column, and we will add our annotations. And I've got some table annotations as well. So let's create that table. I'll do the same with orders. I've got our annotations there, and our invoices, same things, annotations, display, things like that. As I say, we can create these on columns and tables. We can also annotate our indexes to say why they exist. Very useful. We've all had those indexes. You look at it, you go, what on earth is this for? Nobody knows. Everyone's forgotten. We can now actually add some annotations to kind of say what its purpose is. Things like that help you describe and understand its value. So we've created our bunch of annotations, and all of them for all objects are in these annotations usage views. So if I bring this up, we can see we've got our invoice, our tables, our indexes, everything in one location. So it's kind of like a one-stop shop to find everything that you are interested in. And we can see what their values are. Now, looking at this, some of you who've got good eyesight and paying good attention might have spotted a little problem here, or a mistake I made. The invoices, I've got our insert annotation allowed read singular. With customers, it's allowed reads plural. Oh dear, all right, a bit of inconsistency there. That's not great. Similarly, for the invoices, I've only said the values allowed are insert rather than insert and update. All right, okay. So let's fix that. So we can also do this when modifying objects, alter the table. So we can drop to remove them, add or replace to change them. And so let's update those. And now hopefully they've all worked. So yeah, we've gone from allowed reader singular to allowed reads plural, and we've fixed the values. So you can change these after the fact and see what they all are. So just a quick introduction of those. Any questions or comments on those before we move on? No. Okay. Right. So hopefully so far so straightforward. Let's jump back over to the slides. So just to kind of recap on what we're then seeing there. Schema annotations. They are metadata, key value pairs metadata. This means the database doesn't do anything with them, right? You can call the keys and the values whatever you want. The database doesn't enforce any values or properties for them. It's up to you to kind of read those and kind of go, okay, this is what I should do. This is how I should work with these values. So to help future developers, DBAs, applications work with this data in the correct way. But as we saw in the demo, and again, those of you who are paying close attention to the slides may have noticed, again, I made a bit of a mistake mixing singular and plural for these. So we've got our insert date time columns. They should have exactly the same annotations, right? We don't want to be mixing and matching singular and plural or other small variations on the spellings here. It's really easy to make silly little mistakes like this. So the question here is, well, rather than having to, apply it to each individual column, can we share them? Can we just come up with a single definition of an insert date time annotations and use that? So, follow the dry principle. Don't repeat yourself, define it once, and then reuse that throughout your application. So here is where data use case domains can come in. And as I say, these can extend base types with use case information. So I see someone put their hand up. If you've got a question, they say just put it in the Q&A and I'll pick it up when I've got a minute. Okay, so just drop questions in the Q&A. So to create a domain, we've got create domain, give it a name and a data type. And at its most basic, that is all you need to do, right? That is the minimum requirement for a domain. It's just renaming a data type, essentially. However, there are a whole stack of optional properties you can also assign. So we're going to run through not quite all of these, but most of these today and see how they work and what the value is. So right at the bottom here, we can see you've got one of the properties you can assign is the annotations. So let's create our insert timestamp domain. So it is a timestamp. And we'll add our annotations, say it's system generated. These are the reads we allow, and these are the things we disallow, the rights we disallow, insert and update. So already this is quite useful because we can use this in our column definitions and they all have the same annotations, meaning we don't have to worry about making sure we're using the singular and plural or other kind of typos and spelling errors. But we've got those annotations saying it is system generated, but surely we could do a bit better here and actually make it system generated, right? And we probably want to make it mandatory as well, right? After all, every row should have an insert date time when it was actually added to the database. So we want to enforce these properties too. So the good news is we just give it a default and say it is not null, so mandatory. So now having defined our insert timestamp use case domain, we can then use it as a column data type. So we can create our table insert date time and use our insert timestamp instead of a date type. So this is how domains work in the SQL standard. So see, domains are actually a SQL standard concept. It's been around a really long time, actually. And we've kind of taken those principles and extended and improved them. So if to be standard compliant, you would do that. But we've got a couple of extensions. One is the domain keyword, just make it clear it is in fact a domain and not some user-defined type or something else that might be going on. The other thing you can do is actually specify the data type and then domain and timestamp, and then the timestamp. In this case, the timestamp, the data type used here must match the data type for the domain. I'll go into a bit more detail why you might want to do that later. So stay tuned if you kind of like, why on earth would ever you want to do that? So now, because they all use that insert timestamp, they've all got the same data type and they've all inherited those properties from the domain. They've all got the same default. They are all mandatory and so on. So we've got a single definition of what an insert timestamp is. That is our use case. And we're going to use it in our column definitions. So that kind of ticks our first little box here of our insert timestamps, our first common property. Next, let's look at email addresses. Again, this is something which is likely to be in several tables. So the customer table, the email address might be their user or, what it is to log in, how you identify them. For orders and invoices, you might have a different contact or extra contact email addresses just to be, in case you want to contact people in different ways, or maybe you've got anonymous users, that kind of thing. So it's likely email addresses will exist in several of these tables. So let's create our email domain, create domain email, and it's a string, so varchar 320 or whatever. Now, that's a good start. And again, that's useful because it enables us to easily find all the email columns in the database, regardless of what they're called. But we might want to do some validation here as well. Now, validating things are a real email address is a bit of a bigger problem than just the database, right? To be sure it's a real email address, really you should email it, send them a link, and get them to click something to validate it is a real email address they actually own and have access to. But we probably want to do some basic validation and ensure it could be a real email address, which essentially means it's a string containing an at, really, right? We might want to add some extra validation there to be sure it kind of conforms to the kind of basic rules of what an email address is. So we can add a check constraint to our email domain to do this validation and say, we've got our email, we're going to do a regular expression to try and be sure that there is in fact an at in it and it conforms to some of the other rules of what an email address is. Question here is, of course, what is that regular expression, right? Okay. And the old joke that they say, if you've got a problem, you try and solve it with regular expressions. Now you've got two problems, right? So this is complicated and it's hard. So rather than kind of having to come up with it yourself, at Oracle here we've come up with our standard definition for an email domain and made that a built-in domain. So these are domains that are pre-provided in an installation so that you can access and just use it out of the box. You don't need to do anything else to them. So we can look at that. If we look at DBA domain constraints, we can see our domains and you can see I haven't actually put the full regular expression because it's so big it doesn't actually fit on the screen. It's rather large, but we have got some built-in domains and constraints for common business values which have known kind of rules or logic for what they are. So if we've got our tables, we don't need to use the domain when creating tables. You can also add it to existing columns, right? So we've got our email and email address columns already. We can just modify them to add the domain to it. And there's a couple of forms for this syntax. There's the explicit add domain, or you can kind of do it inline, which is a bit like when you change the data type for a column. Now, do note when you're doing this, there is a check constraint on that domain. So what's going to happen here? It's going to apply that check constraint from the domain to those columns, right? So we can see when we look at the user constraints and look at our tables, that constraint is now on those table columns. What does that mean? Well, it means you need to make sure the values in the table or at least could be real email addresses. They've conformed to that regular expression. If you don't, what's going to happen? You're going to get an exception, okay? So you might need to clean your data up a bit beforehand if you're adding domains to existing tables, domains with constraints to existing tables. So, so be aware of that when you are assigning domains or adding them to tables. So that gives us, so we've got our insert timestamp, we've set our properties for that, we've got our email, we've used built-in. You say another common single value here might have statuses, a list of values of the possible statuses a column could have. Very common to have things like opened, closed, cancelled, refunded, paid, shipped, those kinds of things. So let's look at that and let's look at how we can do this. So this is something we've got which is new in 23.4, the most recent release, 23 AI. We've had the kind of beta and the free release of 23 for a long time. Enums or enumeration domains have just been added. So to create these, we just create these, give it a name, say it's as an enum, and then we have a list of names. Okay, so these are the names for the domain, and they have the values 1 to n by default. So the first one, opened, has the value 1, second 2, 3, 4, down to refunded, and so on. So that is our list of values. Now, one of the nice things about these enums is you can then query them as if they're their table to see what those names and values are. We can just select it like a regular table, and there you go. Woohoo! We can see what the names and values for that enumeration domain are. Now, do note this looks like a table property only applies to queries. It only applies in the from clause. You can't insert, update, delete the statuses. You can't change the values for an enum like you would a regular table. Okay, this only applies to queries to see what's actually in there. So that's one nice thing it gives us. But another nice thing this kind of gives us is we can now actually reference the names in SQL like constants and get the values. These values 1, 2, 3, 4, it's not clear what they are, but opened, I know what open means. We can actually use domain name dot name within it, and we will get the value. So we're saying insert the value 1 and whatever refunded was, what was refunded. I think it was 4, trying to remember now. So we can use those in regular SQL statements like constant. So this kind of gives us that kind of named constant property that you might want to have for these kind of these values. We know it's the number one, but we want to actually refer to it by something a bit more legible and meaningful, like open, closed, whatever it is we want to call it. So at this point, I'm going to jump over into another demo and we'll look at how these actually work in practice. Okay, so let's just start. I'll just reset everything, start again, recreate my tables. So start off with, we will create our domain. So one thing you'll note here, I've got create use case domain. So use case is a completely optional keyword. Just to reinforce that they are domains, they are to describe a use case for your data. So we can create our timestamp. It is a timestamp. It's got a default. It's mandatory, and there's some annotations. So there we go. We've created it, and we look at user domains to look at it and see its properties in the database. So having created that, we can then use it when creating our tables. Like I say, we can use it like a data type, which is the SQL standard way of doing it. So we can create our table there. We can use the domain keyword to show that it is in fact a domain, or we can do data type domain name. Right? So they all do the same thing. Okay. So having done that, this gives us a few things. First up, we can now easily find all the columns that are an insert timestamp by querying the data dictionary, find everything for that domain, and we can see where they all are. Hey, we've got them. The other thing here is, by using the domain, we've guaranteed they are all a timestamp, they've all got the same default, and they are all mandatory as well. So it inherits those properties. And as I say, they also got the annotations from the domain as well. Very, very useful, right? So we now got that define it once, reuse throughout your application, so we don't have to worry about typos and other kind of silly mistakes like that. So we can see what it is and we can define it. So that's our insert timestamp. Let's look at email. Like I say, there's a stack of these built-in domains for kind of common values that we might have: variance, standard deviation, currencies, days of the week, months of the year. There's a whole stack of these for kind of common values which exist across all applications to some degree or another. And one of these, as I say, is the email. So sys.emailD. I've done sys just to kind of reinforce that it is in the sys schema. While doing one demo of this, I actually created my own email D, and I was like, why is this not working? What's going on? It's not doing what I expect to do, because it was using my local version rather than the sys one. So it's good practice to schema qualify that with sys. So we alter the table, and that has applied the domain. And as I said, not only has it named it, it's copied the constraint to those columns. So we can now easily find all those emails columns. Again, it's like email, there's lots of variations on how it might be. It might be email address, email, customer email, order email, contact email, that kind of thing. We now know where they all are by looking at the domain. And we have got the constraint from the domain to the table. So we've got test@ting.com. Looks like it could be an email at least. Try it out, and it goes, one row inserted. But invalid.email doesn't have an @ sign in it. That's clearly can't be an email address in any shape or form. So the database will nicely reject it for us. Side little thing, slightly better error messages. Check constraint involving column email. Oh, interesting. I know that there's a problem with this email address. Also, it's a slightly different check constraint error to normal check constraints. So it's 11534 instead of, or a 2292, whatever it is. Right, so we can see it's come from the domain like that. So we've applied that constraint for to the table. Let's now look at these enums. So I've got list of values, and it'll start with 1, and then go 1, 2, 3, 4 in that order. And the same, we can just query it. There we go. We've got see what they all are. Now you might not want to have the values 1, 2, 3, 4. You might want to have, I don't know, character strings as well. You might want to say open, close, cancel, whatever. So we can do that. So you can say explicitly what these values are equal to. So we can change what they are. So let's query that. You can see opened goes to open, closed goes to close. Is that useful in this example? I don't know, maybe not. But you've got that flexibility to do this. These can be any string, any literal values. So numbers, dates, strings, timestamps, whatever they want. Now, do note, they all have to be the same type. I can't make opened one, close, and cancelled some date. They're different data types that going to work. And they do have to be the same data type, but otherwise you can do this. So I don't want this. I want to go back to our strings. Let's drop our domain and recreate it. The other thing to note is we've also got other domain properties like annotations, defaults. So the first one opened is value 1, default 1. So we have a default there of opened. Okay, pretty nice. Okay, so let's apply those domains to our columns, to our order and invoice statuses. And now we can see it's copied those constraints to the table to say it's got to be the values between 1 and 4. Okay, so we can see that property has been copied there. Now, the named constant effect. Nice side effect of this. So these three, I've got 3 inserts here. They all do the same thing for the order status. We can use the value 1. We can use statuses.opened, which maps to 1, or we can use default because it has a default of 1. Okay, so these 3 inserts all do the same thing. And commit that, and we can see that. So we can order status. We get when we do statuses.opened, it returns the value 1. So that's what's stored there. If we want to see the name, we can call domain display. So we can see we've got the values 1. We can convert that to what the actual corresponding name for that is. It's pretty neat, right? So we can also do things like this. We can do closed, cancelled, refunded, insert. We can do it with an update, things like that. You can use it as case expressions, where clauses, anywhere where you could use a string literal values. So we can map those like that. We can see we updated them all to closed, and we got our case expression to say whether it's complete or not. And we can roll it back and do that and see we've got those opened ones as well. So enums, there's a lot. I think these are really neat actually. But there are lots of nice little things you can do with them. So if there's any questions or comments, let me know. I see there's some come in while I've been doing this. So the question is, can you index the enum? So when you're using the enum as a column, so we've got our order status, you can still create an index on this column. I mean, they're still just values, right? So you can create an index on this column as you would normally. If you're asking, can you create an index on the enum itself, the status? No, and I'm not sure why you'd want or need to, because enums should be a relatively small list of things, right? That's kind of the property. You've enumerated a small list, handful of values here, and you might want to query it like a table, but that's about it, right? So you can create an index on the enum column, the column in the table that is the enum, but you can't create an index on the enum itself. And again, like I say, I'm not sure why you'd want to or need to. Okay, question. I don't recall if the annotation has a default value. If it does, would it try to update all the columns you modify if you modify the column? I'm not sure what you mean by annotation has a default value. Well, I'll just go back up to annotations. Let's just go right up to the top. So we got system generated here. So that is the name or the key. I've supplied no value for it. Okay, so it doesn't actually have a value. So I'm not sure what you mean by a default. They say this annotation is metadata. It does nothing whatsoever for this column. I put these properties in here. It's up to you or your future developers and friends and colleagues to actually honor and look at these and go, oh yeah, I should make it system generated and not supply my own values and do that kind of thing. It does nothing in the database itself. I can override this. I can just completely ignore these exist if I'm being belligerent or not playing ball, right? It is just purely metadata. It does not change the column in any way whatsoever. It is up to you to kind of look at those and go, oh yeah, I should not insert and update that. I should just use the default, right? So I'm not really sure what you mean by a default value in the database because it doesn't have one or it doesn't use one as such. Okay, right. Will STDDM have an update to better support STDDM? a SQL developer data modeler, I assume you mean. They I'm not sure what the roadmap is for that. Hopefully the answer is yes. They've got a lot of work to do. So kind of there's lots of new stuff in 23 AI, right? There's a lot of work they need to do to kind of support these things. I hope so. Obviously, if you this is something that's important to you, I'd recommend reaching out to Jeff Smith, and the more customers who complain about it, the higher the priority these kind of things go. Okay, so speak to them. What about segment of domain? Segment of domain? I'm not sure what you mean. You mean like table space and things like that? Again, it's a dictionary object. Okay, the kind of query it is kind of a convenience thing for you. It's not a real table as such, but you can kind of query it like one. So you don't need to worry about storage. You don't need to worry about indexes. You don't need to do that kind of thing. Just think about the column it's on and do whatever you would do for that column. And you could kind of just think of it as a nice way to handle these things. Okay. What happens if an enum domain is dropped and recreated with a different set and or ordering of the values while it's used by some tables? That's a good question, actually. Let's look at that, right? So we've got our domain enum domain on invoices. So let's just let me put that in. Let's remove that, and I got this right. No, not the right syntax. I'm trying to drop. There we go. Let's drop the domain. Okay. No, hang on. Well, there's a couple of things we want to do. Let's drop domain statuses. That's what I'm trying to do. Get with the program. So the first thing to note is it's not going to let me do that because there are columns that use it. So it's not going to just let you kind of pretend it doesn't exist and get rid of it. Now, in some cases, you might go, well, I don't care. I want to get rid of it. And I've just, I want to get rid of it in some cases. And hopefully I can actually, where did I go? Yeah, so we're here. Drop domain. I can say force it to go. Get rid of that. Right. So now it is gone. And that has removed the corresponding constraints from those tables. Okay. Now you might kind of go, oh, I don't like that. I actually want to keep those constraints in place because I want to change the enum definition, for example. So let's just re-add it. Let's just kind of prove they're back there. We've got the constraints there. I can force and then preserve, right? So this is going to keep those constraints on those columns. So we query back, we'll see, there we go, it is there, but the domain itself, the enum itself is gone. If I can go back, it doesn't exist. So we can recreate it with some new statuses, for example. Maybe we want to add in, what's another status? Can anyone think of another status we might want to add in? Open, closed, cancelled, refunded, shipped. Let's go shipped. We can add that in, and then we can re-add it back to the column. Oh, getting interesting here. We'll see we've got our new constraint for the status 5, and then we'll have to drop the old constraint. So it is a bit fiddly. We are thinking about better ways of doing this. This does get quite complicated because there could be lots, potentially hundreds of columns affected by this. And there's like questions around, well, what happens if we get to 99%, 99% of them done and there's an error? Should we roll them back? How does it work? I don't know. It's kind of complicated, right? So if you've got thoughts, please share them because I'd like to know how that works. Can you create a foreign key constraint on a domain? You can create a foreign key constraint on a domain column, right? You can't define you can only define check constraints, not null constraints in the domain itself. But the column that you use can be a foreign key. So I can't do create domain blah 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 foreign key, but having assigned that to a column, you can use foreign key. You can create a foreign key on that. So we can't create a generic foreign key to a table column, for example. Okay, lots of good questions there. Any other questions before we move on? I think, yeah, we covered I think I've covered everything I was going to talk about there. Yeah, let's just undo that. Okay. Nope. All right, let's move on. So just kind of recap on those quickly. So we saw use case domains. So domains are a good way to kind of come up with standard definitions for things like annotations, constraints, other properties for these things as well. And these properties are actually, unlike annotations, which are just free form, you can do what you want with. Domains can actually have properties in the database, like constraints and defaults. There is a whole stack of built-in domains for, well-known business values, credit card numbers, days of the week, at least in English, the English spelling of days of the week, things like that. And in the most recent release, we've added enumeration domains, which allow you to define lists of values. All right, let's move on and talk about money. Right. Okay. So again, this is something which is likely to be in many tables. So products have a price, orders and invoices have the amount you paid, transactions might have a transaction value, and that kind of thing. So money is a bit more interesting than the values we looked at so far, because you notice I've got 3 columns here. Really, when we think about it, generally money is kind of a composite value. Most applications these days, or a lot of applications, need to support multiple currencies. It's not just the currency your business operates in. You quite often will receive international payments. So you need to actually store multiple parts. The actual, value of it, the number comprising that money, the currency for the value, which currency that is in, and you probably want an exchange rate from that currency back to your standard business currency, whatever that happens to be. So we want to kind of combine all of these into one thing. And the way you can do that is with multi-column domains. Kind of similar to the domains we've looked at so far, which are single column domains, but you have a list of the columns, the domain columns, they all have a data type. And then again, they can have optional properties like check constraint, default, that kind of thing. So let's create our currency domain. It has an amount, it's a number, it's currency code, which is char, and it's exchange rate. Seems good, right? Some of you might be looking at this. So those of you paying attention, looking closely, might notice there's an extra keyword here, strict, for the currency code. Like strict, what's that about? What's going on there? What does he mean by strict? Well, to explain, let's look at these values. I defined the amount of the price as a number 10 to, so pounds and pence, dollars and cents, euros and cents, that kind of thing. But we could actually store it differently. You could just store it in the minor unit, so just in pennies, just in cents, as an integer. Or maybe as you grow, you start to realize that some currencies actually have 3 decimal places. A lot of the North African, Middle Eastern currencies and dirhams actually have 3 decimal places, and there's 1 or 2 which have 4 as well. Okay, interesting. So we've come up with a default definition here, but we might need to change or adapt that on particular columns for various reasons. Similarly, exchange rate, I've just said it's a number. I don't know how big, I don't know what scale of precision, but we probably just want to match an API. Now, maybe if we're getting data from an API, and we might have different APIs, our pricing API might be different to our payment exchange rate API, right? They can be in different things. So we might want to match the scale and precision for those APIs. So we've come up with defaults here, but on particular tables or particular columns, we might want to have different ones. ISO currency codes, however, 3 characters. They are always 3 characters. It's literally part of the definition of what they are. USD, GBP, EUR, they are all exactly 3 letters long, right? So this is where strict comes in. It says it must be an exact data type match. So when associating a domain to a column, you must always have a base type match. You can only assign timestamps to timestamps, dates to dates, that kind of thing. But with strict, it must match exactly in terms of the scale and precision as well. So, for example, I can do something like this. I can have our order items and say the total paid is actually going to be recorded in pennies or cents or whatever your minor unit is, and as an integer. And we can have a different scale for this exchange rate. We can do this because these are both numbers at the root of it, right? However, I can't do something like this, create currency code, which is a char 99 char, because it is not char 3 char, right? This will give us an error. It has to be an exact data time match. So I have to make it a char 3 char like that. So strict is in those cases where you say, we know exactly what this value is, and it must always be that and nothing else, right? Most of the time, you don't really need to do this. Well, you may not even want to do this. So that's awesome. We've got our currency domain and made of 3 parts, and we say currency codes are all 3 characters long. But there are other challenges with currency values as well. So, for example, let's say we try and sort by the values. If we've got multiple different currencies in this table, well, there's all sorts of different exchange rates, right? Currencies like Japanese yen and Indian rupees are many multiples of US dollars, euros, and British pounds. So we just sort by the numeric value, our Japanese yen and Indian rupees are going to trend towards the bottom of our data set. But are they actually more expensive when we've converted them, right? Really, what we probably want to do is convert them to our standard business currency, US dollars, for example, and then sort and compare in our standardized currency. Okay, so how can we do this? Well, we want to be sure everyone's doing currency conversion in exactly the same way. So this is something else we can do with domains is we can define standard display and sort rules. How we do it? We have an order expression. So for sorting, we just probably want the amount times the exchange rate, right? So multiply those together. But when it comes to displaying, we probably don't want to just add those, multiply those, because we'll end up with some number with lots of fractional precision, right? We probably want to round it to how many minor units there are in our currency of choice. So 2 for most people. And we might want to add some extra formatting, the decimal points or the commas as appropriate, and we might want to show the original currency code as well. So we can add a display expression to show the original currency and then round to 2 decimal places so we can get our actual dollar value, dollars and cents value. So having defined these, in order to actually activate them and use them, we need to call the domain display and order functions correspondingly. So that will show the result of those expressions for those values. Do that, and we can see that our Japanese yen isn't actually the most expensive at all. It's the cheapest once we've converted it into standardized rules. So these are useful when you've got non-standard logic that you want to apply for sorting values and displaying them. Again, bear in mind that you might need slightly different logic for all these depending on your use case and what you're doing, right? All right, finish up. Postal addresses. Now, this is where it all gets lots of fun, right? Every country's got its own approach for what it considers to be a postal address, what parts it has, what a zip code or postal code is, and so on. So to start off with, we'll probably do something in, street, city, state, zip code, country code. But over time, we edit small tables and we just kind of give up, right? And just go address line 1, 2, 3, 4, postal or zip code and a country code, right? So this kind of does the job, but quite often we might want a bit more formatting here. We want to be sure, if this is a US postal address, that the zip code is a US zip code, it's the numbers. If it's a UK postal address, it's the rules for the UK postal codes and so on. So we could try and create one domain, just a giant address domain, and then have check constraints for the postal code and other parts like that. This quickly gets very, very complicated, right? As I say, different countries have different formats, particularly for zip and postal codes, but also what parts there are in address. Some are mandatory in some countries and not in others, that kind of thing. So to keep a simple example, we've got the US or Oracle's based and UK where I live. They're very similar formats, except US zip codes are numbers and UK postal codes are a combination of letters and numbers and kind of something a little complicated like this. So rather than try and come up with one giant address domain, we could create a domain for each country. Right? So we can create a US address. We'll split the problem up. That's a good programming principle, make it smaller problems. So we can create our US address and have our validation that zip codes numbers. We can have our British address and again validate the postal code as appropriate. Sounds good, right? What could possibly go wrong here? Well, let's try and add these to the tables. So let's add our US address to our customers table. That does the job. Trying to add it to the British address to the same table. What's going to happen? You get an error, right? A column can only belong to one domain. You cannot assign multiple domains to one column. Okay, so this is a restriction which maybe we might change at some point in the future, but currently you can only assign a column to one domain. But let's fast forward sometime in the future. Imagine this, or let's imagine this restriction didn't exist. How would this even work? We've got two domains. They've got completely different constraints for zip and postal codes. They conflict. We could, if we assign both of them to the same columns, how could you ever insert data? Well, you couldn't, because valid zip codes are invalid postal codes and vice versa. How the database needs to know which domain to use for that particular row. Is it a US postal code address, or is it a UK address, and so on, for example. So to get around this, we've come up with the concept of flex domains. So these define a supertype subtype relationship. So the supertype is your flexible domain, and that has a discriminant column. So the column which chooses which subdomain to use. So the country code in this case. So the address has the country code, and then we choose the subdomains based on that country code. So to do it, we create a flexible domain, list out the common values for those, the discriminant column, which is the country code, and then a case or a decode expression to choose which subdomain to use for each row. And then we can use that in our addresses table. Notice we've got the using clause to specify the discriminant column. So I'll jump over to a demo to show that as those work. So I see there's some comments come in. Can we associate temporal validity with a domain? The temporal period, you mean? No, you can't associate that with the domain itself, but you can associate it to the domain, the columns, once you've assigned them to the table. So yeah, temporal validity is not something we have at the moment. Annotations new to me besides domains. Are annotations just hints, or are they enforced by the database? So I'll reiterate, annotations are just metadata. They do nothing. Annotations do zero, zip, nada, nil, zilch in the database. They are free form. They are entirely up to you. Domains, however, can have properties in the database, like defaults and constraints, okay? So adding that annotation does nothing to the database. It is up to you to make sure you respect what those annotations do, okay? So just make that absolutely crystal clear. Okay, so we've got let's make our currency code. And we've got our 3-column currency code. We'll have our prices, and we'll associate our domain with it. Now notice char for char. Oh, well, that's not going to work because it's a strict. This is strict. Okay. Now you can make it a char 12 bytes, and you'll go, oh, that works. What? Why does that work? Well, there's a in UTF-8, there's a 4:1 byte to character ratio. So 12 bytes, 3 characters could be up to 12 bytes. All right. So in fact, these are the same. Char 3 char and char 12 byte are the same thing in this character set. In different character sets, it may not be the same thing, but this is just a little wrinkle to be aware of there. But notice the exchange rate and the price, they don't actually match what those are. Okay, let's create our order items. And then again, we can add the domain currency after the fact. And then we can find all our currency columns in the database, querying the data dictionary. Let's put some values in. We got our rupees and our Japanese yen, sort by total paid, and lo and behold, in rupees and Japanese yen go towards the bottom. Okay, let's convert them into a standardized currency. Let's add our display or order expression, sorry, to sort the values, and our display expression to show the values. And you can see I got some formatting for decimal points and things like that. We call those, and voila, Japanese yen are actually the cheapest value in constant currency converted to our standard business currency. So we've got our rules. So we have to call this. If we just sort by the columns themselves without this, it just does normal sorting. You have to pass them into the function to actually do this. Okay. Flexible domains. Let's look at, so let's create our US address. So you have to create the subdomains first. Create our US address, our British address, and then we'll just create a generic fallback global address. Just say it must have at least one line in it. Okay? There must be something in there. Other than that, we're not sure. Then we create our flexible domain, saying the country code is what decides which subdomain to use, or which of our subdomains to use. British for that, US, and otherwise we fall back to our global address. Insert that in, create our addresses table, and we can put some things in. So there's some values which are valid. These work, they conform to the constraints. That's good. Or those values go in the database. Let's put in some junk. Right. So a British GB address country code with a US postal code. What's going to happen? Well, we're going to get an exception because so column involving country code and postal code due to the domain constraint. We've violated it because it is not a US. We've got the country or the postal code wrong. One of them is wrong, right? US addresses must have a state. So I've only put in a street and a town or city. I haven't provided the state. So again, this will also get rejected because that value is mandatory. So those values haven't gone in the database. So I see there are a couple more questions. If you want to keep asking your questions, keep them coming in. We are on the hour, so I'll wrap up and then we'll come back to the questions because some of you may need to head off to your next meeting, that kind of thing. So to wrap up quickly, so we saw here multi-column domains, so composite values, think things like currency amounts, which actually have multiple parts to them. Temperature, readings. There you've got the actual temperature and the units it's in. Is it Celsius, Fahrenheit, Kelvin, that kind of thing? So we can have multiple composite values. Particularly for, any of these domains, but particularly for composite values, you might want to have special rules for how you want to display and order them. So we've got the functions, the display and order expressions, and the domain display and order functions to activate them. And then finally, flexible domains to kind of have that supertype, subtype type relationship. We saw addresses here. Again, I mentioned temperature. That's another example. You can have a supertype address, temperature, with the units, and then subtypes for Fahrenheit, Kelvin, Celsius, with a check constraint for absolute zero, because they've all got absolute zero is a different numeric value for each one, right? So we can use that and do things like that. So we've covered a lot here, and some of you at this point be going, well, how did this help again? I've lost. Where were we? What's going on? Help. So just a final recap on that. So we saw we had schema annotations. They are key value metadata. They do nothing in the database. It is up to you to make sure they are respected. Okay, this is just information for you to help you and other developers and DBAs and apps understand and work with the data. If you can put whatever you want there, the database is not going to do anything with it. Data use case domains, on the other hand, have a data type at a minimum, but they can also enforce other properties to represent that use case. Things like constraints, default values, is it mandatory, rules for displaying and sorting those values. So annotations, just information, does zero in the database. Use case domains, data type with extend that data type with properties to make sure it is actually held in the database. How does this help us? Well, it helps with data discovery. We can query the data dictionary to find all the email columns in the database because they've all got that email domain, or the insert timestamp, or the currency, or whatever it is. And the annotations help you understand how to actually interact and work with it. So it helps you find all these values, and it also helps you manage them consistently. We've got a single place to define that check constraint for what a currency code is, or the annotations for an insert timestamp, that kind of thing. Define it once, reuse throughout the application. So hopefully this will help it easier for you to build these models and understand and work with your data. So to finish up and say, I really hope you enjoyed this. More importantly, I hope you learned something. I will see you next time. So 18th was scheduled for the 18th of June. Really hope you can join us and look forward to seeing you again next time, folks. Bye-bye.